In this video, we'll look at one last example of looking at a graph and describing its domain and range and determining whether or not that graph represents a function. So remember one more time, the graph that we discuss is the part that we plot. We're not talking about the grid. So the graph that we are describing is this orange sideways parabola, and our goal is to determine its domain, its range, and whether or not this orange parabola represents a function. So I have my x and y axis labeled already. And remember, for domain, that is my x values. So it's not where I touch the x axis, it's where I follow the x axis. So as far as how far we follow the x axis to the left, well, the furthest left point on this orange parabola is right here. And that happens to be on the x axis, but it doesn't have to be on it. It's just this is where the parabola turns around. So our domain for this orange parabola has a lowest value of an x value of 1. So my domain is going to start with 1 because that's the lowest x value contained on this orange graph. And as far as the highest x value that gets used, well, remember the x-axis goes left and it also goes right. So we want to discuss for how long will this orange parabola go to the right? Well, as you see, we have these arrows on the end indicating that the graph will never stop moving to the right. It goes on forever. And so our highest x value that will ever be used on this parabola is infinity, indicating that this graph goes on to the right forever. And just like before, if we can equal a number, we will put brackets around that. And if we cannot equal a number, we'll put parentheses around that. And infinity is an idea, it's not an exact number, so we can never equal infinity. So for range, that is how far we follow the y-axis. So the y-axis is vertical. So when we talk about range, we talk about how low does the graph ever go and how high does it ever go, because the y-axis goes low and high, down and up. So as we trace this orange parabola, yes, the obvious motion is that we're tracing to the right, but we're also falling down as we're tracing. So when we approach this arrow here, it indicates that we're moving to the right, but we're also going to continue moving downward. So the graph technically is going to keep moving down forever and ever. So if that's the case, the lowest y value that will get used is negative infinity, because the graph will never stop moving downward. And in a similar fashion, as we trace the graph in this direction, yes, we're moving to the right, but we are also moving upward. And so as we see this arrow, that trend will continue. This graph, yes, goes to the right forever, but this branch of the graph is going upward forever as well. So the highest y value is the highest number possible, which we represent by the idea of infinity. So because the graph goes on forever upward, our range will end with a value of positive infinity. So please note, we do have negative infinities and positive infinities. We do need to show that negative in front of any negative infinity we have, because that negative in this case means downward forever, and the positive here means upward forever. Okay, so keep track of your negative signs, but we can never equal infinity, so we'll put parentheses around this range. And in terms of this being a function, there are a lot of places we could check. Pretty easy place to check would be, for example, right here. Again, you're not trying to make it be a function, you are trying to determine if it is. And so if there's any place where you can draw a vertical line and touch your graph in more than one location, intersect in more than one location, such as here, this would not be considered a function. So we're going to say no, this parabola does not represent a function. And the reason is that it fails the vertical line test, which again we can represent by just putting fails VLT. Sorry, this won't go away. It fails the vertical line test, so fails the VLT. So in summary, we are going to use interval notation for our domains and ranges for graphs throughout the school year. As far as determining whether they're functions, that's just for a brief period here, but we do want to get used to this notation for domain and range.